Hello students, I am Manish Gupta. We are going to learn AP Physics. Unit 1 will be the kinematics. This is the second lesson for the kinematics. In first lesson, if you haven't watched, you should go back and watch the first lesson. In last lesson, we took the velocity as constant. In this lesson, we are going to introduce acceleration, because when you are moving a car is moving, sometimes it gets speed up, sometimes it slows down, it changes the velocity. So we are going to talk about acceleration. Acceleration is the rate of change of velocity. Acceleration we can write as final velocity minus initial velocity over change in time. So students, we can write it as A as delta V over delta T. If we will readjust it, we will get delta V as A delta T, right? We can write delta V as Vf minus Vi equals A delta T. So see the magic. Vf will be initial velocity plus A delta T. So the time you saw velocity and body got accelerated, then final velocity will be Vf will be Vi plus A delta T. Students, you encounter two situations when velocity is changing, either speeding up or slowing down. So when you are speeding up, that means your velocity, magnitude of velocity is increasing, right? So in this situation, to speed up, acceleration is supposed to be in the same direction. Acceleration will be the same direction as velocity. Second situation is the slowing down. In this case, acceleration will be opposite direction to velocity. This is the case of slowing down. Let's take an example for this. A family exciting drives to home plus for some well choreographed shopping. For each of the following cases, determine the direction of the acceleration of the car. First situation is car travels east and speeds up. So if it's moving, let's take this as east and this as west direction. So if it's moving in east direction and speeding up, that means acceleration will be in the same direction, eastwards. Car travels east and slows down, so acceleration will be westwards. Third situation is car travels east at constant velocity. So for constant velocity, acceleration will be 0. Fourth situation is car travels west and slows down. So velocity will be in west and acceleration will be opposite to velocity, that means eastward for slows down. Fifth situation is car travels west and speeds up. Okay, so velocity will be in same direction as acceleration because it speeds up. Now students, you understand acceleration, speeding up, slowing down. When we are considering a motion, there will be some initial velocity, final velocity, change in position, acceleration, some time period, right? So we have 5 kinematic equations which can help us to learn the situation. For an object in motion, there are 5 primary kinematic quantities to describe the motion. Primary quantities, we can first have initial velocity, second final velocity, and change in position, displacement, acceleration, period of time for problem. So students, equations we have, first equation we have delta x equals vi plus vf over 2 into t. Here you saw we have 5 terms, we have 5 quantities, vi, vf, 1, 2, 3, change in position, 4th acceleration, 5th is the time period. Students, first equation we have delta x equals vi plus vf over 2 into t. If you will see, each equation contains only 4 quantities. First equation has displacement, initial velocity, final velocity and change in time. T is the time interval, change in time. So it's the no acceleration equation. It's the no acceleration equation. Look at the second equation. Final velocity is initial velocity plus acceleration into time. So it's the no displacement equation. No displacement equation. Third one is, third equation we have displacement equals initial velocity into t, time interval, plus half into acceleration into time interval square. Delta x equals vit plus half a t square. First we will learn the equations, then we will learn the application of that with some examples. So here you will see it doesn't involve final velocity. So it's no final velocity equation. No final velocity equation. Look at the next equation. Delta x equals vft minus half a t square. So you will see it's no initial velocity equation. No initial velocity equation. So students, we talked about we have 5 equations. So fifth equation is final velocity square equals initial velocity square plus 2 times of acceleration into displacement. So what is missing? Time period, right? So it's the no time equation. All five equations only applicable when acceleration is uniform. Above equations are only applicable when acceleration is constant, or we can say uniform. I hope you got these equations. Let's apply, then you will understand more. Right approach to solve a question will be, students, write down the knowns and unknowns quantity from the equation, from the question, then identify the suitable equation which involves knowns and unknowns or relates the knowns and unknowns, then solve using the algebra. Let's take this example. A 2014 Hyundai Elantra uniformly accelerates. See, it's saying uniformly accelerates from 12 meter per second to 20 meter per second in 3 seconds. What distance did it travel in that time? So students, if you will see, there is no change in velocity, right? There is no change in direction. There is change in velocity. Initial velocity is this and this. So if you are looking for a distance, here distance and displacement will be same, right? No change in direction and moving on a straight path. Initial velocity is 12 meter per second. uniformly accelerating with some acceleration, and final velocity is 20 meter per second. So we can identify the quantities Vi, Vf, A, delta x and t. So students, if you will see, we have given initial velocity as 12 meter per second. Final velocity we have given 20 meter per second. Here it's talking about acceleration, that it's uniform, but value is not given. Time interval you will see is given 3 seconds, and it's asked about the distance, and here distance and displacement magnitude will have the same value. So let's calculate this delta x. We need no acceleration equation. We need no acceleration equation, right? So no acceleration equation, delta x equals Vi plus Vf over 2 into t. We have 12 and 20 over 2 and time interval is 3 seconds. So we got 32 over 2, 16, 48 meters. This will be our answer. I hope you understand this question and concepts. Let's go to another example. 2013